Yes,
I didn't 3.
this is coordinate 2. So we go in a C shape. So I would start here. So this is coordinate 1. Then we go over in a C pattern. We are in coordinate 2.
What?
Then we're in coordinate 3.
What? You mean quadrant 3, right?
Yeah, what am I saying? Coordinate? Yep, whatever. Okay, we 1, 2, 3, 4. Yep.
Can I just go to the get something?
Yeah.
So why is it a C?
Okay, because I start in quadrant 1, then quadrant 2, so I'm going in a pattern of a C. So start here and go 1, 2, 3, 4. So you always remember. Just go in a pattern of a C.
Can we draw that C?
You don't have to. I'm about to erase it.
Oh, okay.
That's just if you want it to help you memorize it.
Why is this like universally important, like the graph?
Like X and Y?
Like the graph itself, according to
Like 1, 2, 3, 4?
Yeah.
Quadrant? Well, this is X, this is Y. So we're talking about the coordinate plane. Because this is like 2 dimensions.
Oh.
And we want to, I mean, you want it to be pretty similar throughout everything. So when we're talking about like a point, like this isn't positive over here. Like this, you want to go this way positive. You want it to just be consistent throughout everybody. I guess. Yeah. Okay. Dizzy, I'm going to draw a line.
Okay.
And I'm going to call it really particular. Very important.
Okay.
Okay. I'm going to draw it right here. Right here. Right at 0. X-axis. This is called the initial. No, initial side. Initial side. So that's where we always start. This is 0 degrees. 0 degrees. When it's flat on the x-axis, 0 degrees. Now, Declan, I'm going to keep going. I'm not just going to end there. If I took another side and I kept going, tell me when to stop, whenever you want to stop. Okay, thanks, Declan. So I'm going to stop right there. This is called the terminal side of an angle that we just made. So we went from the initial side to the terminal side, and that is our angle, and let's call it theta. Now, do you all know what theta is?
Greek.
Sorority.
Okay, yeah, it's a Greek symbol. This is theta. It represents right now an angle of our problem. This is our angle.
Wait, what's it called?
Theta. Theta.
What the heck?
I've seen it like every single angle from.
Yeah, you're gonna see a lot.
Wow.
Now, we had this being 0 degrees.
Oh, it's 0?
Yep, if I'm starting at the x-axis, it's 0 degrees. What would it be if my terminal side ended right here? How many degrees did I start? Yep, 90 degrees. I just made a 90-degree angle. Now, Lucy, if I keep going to this one over here, in between quadrant 1 and 2, what would this be? How many degrees?
180?
Yep, 180 degrees. For my last one, what's down here, Ben? What would this be? How many degrees? Yeah, 270 degrees.
Oh.
Is it the color?
Isn't that board's a little shiny? That
Shiny?
board's better.
Right enough. The glare.
Okay, so we were talking about quadrant 1. The degrees have to be between which two?
90 and
Yep, 90 degrees
Yeah.
and 0
That's way
degrees.
better.
Beatrice, what about quadrant 2?
180.
And if I'm in this quadrant, I'm between which two?
90.
Yep, and 90. Kian, what about quadrant 3?
36. No. 180.
Mm-hmm.
It's greater than. No. It's less than 0.
So I'm in this quadrant right here.
Yeah.
So I went from 180, and this quadrant ends when I get to how many degrees?
180.
So I start at 180.
90.
When do I end?
170. Wait. 270.
Yep, 270. So all the angles in quadrant 3 are between 180 and 270. Okay, what about quadrant 4?
270, 20.
20 or 360. Either one.
Yeah.
I'm going to say 360 degrees. So those are the quadrants and what angles are in which quadrant. We would, Jade, give us a degree, any degree you want.
1. Okay.
A harder one.
167.
Okay, 167. What quadrant would that be in? 1, 2, 3, or 4?
3.
2.
No, 2.
Two.
1. Oh, 167.
167.
Oh,
Two.
2.
3. It's a D.
2.
2.
Three.
It should be 2 because I'm not above 180, but I'm greater than 90, so it should be about like right there. Actually, exactly where mine is pretty much. Okay, what about 120 degrees?
122.
Still.
It's
2.
a 2.
Okay, I want you to sketch it now. Sketch me a coordinate plane where my terminal side ends and we make a 120 degree angle.
So, the one we just drew was that.
That's more like,
360.
How do you guess?
Wait,
I don't
what?
know.
okay.
Drew without protracted X.
Wait, I'm confused. What do we do?
So it's gonna be like this
Draw
way?
120 degrees.
1/3 away.
Always.
Yeah. Yeah.
Oh, because I was having X. Oh, it's
This is 90.
Can we draw another
where
graph?
that starts.
Yeah, I would draw another graph. So,
35, so it'd be right here.
what quadrant is 120 degrees in and sketch? I want you to label your initial side and your terminal side for this one. Okay, I'm gonna go around. Tell me when to stop. Right there?
No, I don't know.
Stop.
Right there? So my terminal side would be right there. About.
Yeah.
So what quadrant are we in?
3. 2, I mean.
Yeah. And what would my theta be here?
Oh, we gotta
Q2 90 lesser than the other.
How many degrees is theta in this example?
120.
Yep, 120. Okay, now I want to see what quadrant 280 is in. Nope, not 280. 480.
What is that symbol?
Oh,
Theta?
it would be in quadrant 1. Right? Or no.
Sketch it.
Oh.
It's gonna help you. $480 degrees.
Why?
So 480
Yeah,
degrees.
that's 2.
We say why?
Yeah? No, I thought it was a part of this problem, so I'm kind of slow, so.
Okay, that's okay.
Yeah, me too.
It's sort of a it's intertwined.
Yeah.
And I want about 120 degrees about it. It's in between 90 and 80, but it's closer to 90.
How do we do this?
90 and 60 degrees off.
Go 480 degrees from the initial.
Yeah, so now I'm going 480, right? So,
I'm still back.
ready? If I go here, how many did I go?
90. 180. I don't know.
270.
Oh, yeah.
And what if I go all the way around? That's how much. So I have to keep going. That's cool. We go, wait, so what if I,
Oh, to get to 40.
yeah, stop when you get to 480.
Okay.
Yeah.
It's the same, right?
So, I have, oh, that was very big. Okay, this is my initial side. Dad, you tell me when to stop, okay? Okay, I'm gonna circle around. Boom, boom, boom. How many am I at right here?
7.
How many am I at here? Okay, how many am I at
Drawing
here?
Fibonacci sequence. Oh,
I
really?
don't know. 360.
Gut flex. 300 or 400.
300, 400,
50.
60.
I think it's
450.
450.
Yeah.
Yep, and then I keep going up more, right?
Yeah.
You can't go
stop.
beyond 260.
Yeah, I can, because that means you just kind of keep going. But wait. I like Ian's question. This is our terminal side, right? Okay, so what is theta right here? I just want that theta. What is that theta?
120.
So I did 360 minus 480 because I went around and I was left with 120. These are both 120. Let's do one more. I want you, which direction have I been going in this entire time?
Clockwise. Or yeah, the counter.
Yeah, so this is counterclockwise. So my next one, I want you to find negative 240 degrees. If I'm going negative, what direction do you think I have to go?
Backwards.
Yep, so clockwise. So now I go clockwise. Oh, we have to go clockwise. So I got my X and Y axis. And I start with my initial side. But I'm no longer going to quadrant 1. I'm going to quadrant 4. And I'm going to keep going. Always start at 0 degrees. And then move over. Yep, negative 240. So right now, if I go from here to here, what is this line? Positive, negative. Negative. So if I go here, how much is this one? How much would this one be? Yep, so it's gonna be in between these two. I just gotta figure out where though. Okay, who wants to tell me to stop for this one? Stop. Okay, yeah. Okay, ready? I gotta go clockwise, right? So am I going up or down?
Down.
Down, okay.
Stop. Really?
I think I have to keep going. So right here I'm at negative 90, negative 80.
Right here.
Yep, about right there. So this is where my initial is. This is negative 240. Now, I don't want negative 240. I want what theta would be between these two angles. So what is theta?
120.
Yep, 120. All of these angles is 120. So these are called coterminal angles.
So it's like the theta is like the universal angle of every.
It's in between our initial side and our terminal side. That is what theta is in all of these.
Oh, that little.
So initial side
How do
to
you
a,
find it though?
Oh, okay.
by doing our initial side, going over how much we just went over. And then 240. If I do 360 minus 240, what do you get? Yep, 120. I gave you this example. This was an example.
Yeah, but
You want to do an example? Okay, let's find two coterminal. Okay, we need to find coterminal first. Coterminal angles. Since all these angles share the same terminal side, they are all called coterminal angles. There we go.
How do you say that one?
Coterminal. Is that the way you're talking about?
Yeah.
Okay, I want you, once you're done with it, give me a thumbs up.
Can we have a break after this?
Sure. After we do this, we're gonna do this on the board, and then,
Okay.
yeah. Okay, we're gonna get into groups, and we're gonna find two coterminal angles of 130 degrees. I want one positive and one negative. Okay? Mm-hmm.
On the board.
I'm gonna give you groups. I'm just waiting for everyone to be done writing. Good?
Yeah.
Okay. Should I do random?
Yeah.
Okay. I'm gonna move this over that one so I can make it. Okay. Let's get random. Oh, it's right there. I'm not gonna fully type out all your names. Jade.
Excel sheet.
I don't know where that is.
It's open on the bottom, on the bar.
Right there. Oh
Hmm.
wow. That's nice. Probably like one of the smallest classes.
Yeah. Not the smallest though.
Really?
Oh my god, no.
What's this one?
Third hour?
With,
I think it's. I think it is.
Is it AP Calc?
I know.
No.
Oh no, I guess that class is huge.
That's second out. That's huge.
Well, I would assume because that class is pretty smart.
Okay, the computer's bugging out. I'm getting text. Jade. Kian.
we're gonna become the.
Beatrice. Lucy. Declan. Wenzel.
This.
Debbie. Oh my god. Debbie. Yell. Okay.
Wenzel.
I have Wenzel. Oh, I typed a W and it's a Q.
Yeah,
Okay.
you really did. Whoa, come on.
Okay. How many groups? We're gonna do 3 groups. How many times do you want me to do it?
Once. One and done.
One done? Fine. Okay. There's your group. Wenzel,
Bro,
Desi,
Declan.
Declan. One group. Jade, Kian, Jade, another group. Yao, Benj, and Beatrice. All
What's
in
N?
another group.
Oh my gosh.
The genius is with your side.
Okay. Find 2 coterminal angles of 130 degrees.
He's like,
You lose that fast?
Huh?
Lose that fast?
Yeah.
You right, Debbie? There's this time I was like, also, when that's how long
I lost to Sebastian in like 4 or something. It was pretty fast.
What should we be doing right now?
Like break.
No, because you're wasting brain big time.
Oh.
Because we're all stalling. We should be sitting down in our seats right now so we can keep going. Thank you. Okay. We went over coterminal. Oops, okay. Now, we don't just talk about angles and angles. We also talk about them in radians. Do we know what radians are? Have we heard of what radians are? Okay. So, let's go from angles to radians. So I'm going to start with my normal circle as before. let's go back. We're going from degrees to radians. We talked about angles, which they were in what? What's my label for all the angles that we've been doing? Yep, degree. Now we're changing our label to radian. So let's start with my circle. Got an X and Y axis. We have my center, and we have a circle. Now, radians are all about pi. All radians are going to have pi in it. Now, in red, I just drew the circumference of a circle.
Which is pi.
Not exactly. You're going to learn what circumference is. So, circumference is 2 pi r, right? Okay, so in the unit circle, our radius is always 1. So, if my radius was 1, what would the circumference of the circle be?
2 pi.
Yep, so it would have been 2 pi. C equals 2 pi. So that means this entire length of the circle in R is actually 2 pi. Not pi, but it's actually 2 pi. Yeah? Okay, so if I went halfway around the circle and I did a semicircle, how much would that be?
1 pi.
Yeah, just 1 pi, so just pi. So if I go all the way around, it's 2 pi. Halfway around is just pi. So what if I just go a fourth of the way around?
1/4.
Mm,
No, 1/2.
1/2. Yep. 1/2. Now, okay, so I'm going to from 0, then I went to pi, halves, pi. What would this one be down here? The fraction.
Maybe
3/4.
3/4.
3/4 pi.
So this is half a pi, right? Okay. So each time I go, oh, each quadrant is half a pi.
Oh.
So pi half.
Oh, it is.
1 pi. So 1.5 pi.
Yep, which as a fraction is
3 halves.
3 pi divided by 2. So what is 1/2 plus 1?
1/2.
Yeah, how do I write that as a fraction?
5 halves.
5. No,
3
3.
halves.
Yep, 3 halves. So if I wrote pi divided by 2 plus pi. So I went from here, then added a whole pi. A whole pi. What would that simplify to?
5.
3 pi.
3 pi halves. Yeah, what's up here?
Does that say 5 pi?
That's 3 pi. I'll write it better.
No, the other one.
This one?
On the plus pi bottom. On the right. On the right. The equation.
Here?
Another one. Another equation.
Here?
Bottom. Yeah.
Pi divided by 2 plus pi equals 3 pi divided by 2? Yeah. Okay. So this would have been 3 pi divided by 2. Now that's in pi, or aka radians. If I write it in terms of pi, it's radians. But we already know these degrees, right? Here, what degree am I at?
0.
Okay, 0 degree. What degree am I at from up here?
90.
90 degrees, yep. What about over here?
180.
And what about down here?
270.
270. So we already know that 270 degrees equals 3 pi divided by 2. We know this for all of them. So 0 degrees equals 0 radians. 90 degrees equals pi divided by 2 radians. And 180 degrees equals how much?
50 pi.
Yep, just pi radians. We're talking about how much, what part of the circumference we're talking about. So the entire circumference is 2 pi. And once we get to 180 degrees, So we're talking about half of it. So half of a circle is 360. No, a full circle is 360. Half of it is 180. So half the circumference would be pi. So full circumference is 2 pi. So we've got our last one. 360 degrees equals how much radians? Yep, 2 pi radians. Do we like radians so far, or do we like degrees?
Degrees.
Okay, well guess what? There is a formula to do that, to just switch them. So we can go from radians to degrees. And then we have also degrees. Oops. Yep. Degrees to radians. Which one do you want to learn first?
Radians.
Radians to degrees. Okay. Now I want us to look at this one right here. 180 degrees equals pi radians. Okay, that is true. I can also write this as a clever choice of 1, which is pi radians over 180 degrees. Okay, that just equals 1. That's a clever choice of 1. Okay, we're going to use that. So, radians 2 degrees. Radians 2 degrees. Okay, give me any radian you want. Not one that we've already done.
50.
Has to be in terms of pi. So pi, 5 pi.
Yeah.
Okay. I'm going to use that. We're going to do pi divided by 5. Okay. Pi divided by 5. We're going to use what we have above, the pi. Now we want this degrees. So our radians has to go on the bottom. Pi divided by 180 degrees. That's all we have to do. These are both in terms of radians, right? So our labels just cross out and we're just left with degrees. So we need our calculators for this.
Is
Everyone?
that 55 radians or pi?
Pi. Okay. Pi can be written many different ways. Pi can be written like this. This is how I write it. Also be written like this. Or like that. What is it? Yes. I'm a number 1 person. Yeah. I'm used to number 1. You used to me doing number 1 forever. Okay. Who has calculator on them?
Oh, I did.
Oh, everybody?
What's the radians stand for again? The degrees type?
Radians is how much, like, out of pi we're going. Radians is how much is, like, the arc length. Remember arc length from geometry? Okay.
Exactly why I'm not going to do that.
So over here, the entire circle, this entire length of that red, if I stretched it out like in a line, you know, like cut a circle and stretch it in a line, that was our circumference. I'm talking about just like this length of it. Yeah. So I'm talking about this. This would be pi divided by 2. So pi halves. Yep. Okay. Everyone needs to get a calculator.
Yeah.
Yep. Okay, what did we get for this one? Okay. Do you want me to help you punch it in? Okay. If this ever turns on, I will. Okay. Hit the on button.
It's 36. Show your work. What?
36.
180 divided by 55 radians.
That's
Or not 55.
Okay, it doesn't work. Apparently, it doesn't want to work for me today. I think it's just like really buffing right now.
After B.
Okay. Do you all get 36?
Yeah.
Okay. Does anyone not get 36? I will show you how.
Wait. How do you
Okay.
How do you type radius?
And I just cleared everything.
Press alpha, Y, then hit 1. That gives you a fraction, right?
Y equals? Alpha Y equals?
Yes, alpha Y equals. Okay. Now
Oh,
do
yeah.
second, and the caret button has pi on top of it. So it should have
I got
pi.
36.
Do
Second one. Wait.
I just did the easy one. 180 divided by 5.
Okay. Sorry, I need to physically hold it.
You just
Otherwise.
no.
Okay. Alpha Y equals 1. Now do second. Pi. And then do 5. And then parentheses, like out, go out. Parentheses 180 divided by pi. So we should have got 36 degrees, right?
Yeah.
Yeah, okay. 36 degrees. Okay, that's how you change radians into pi. Not, oh my god. Radians into degrees.
Maybe brain break.
We only have 5 minutes.
Yeah,
We're gonna do our last one here. And then maybe.
Quick?
Yeah, well, yeah, just degrees to radians.
Okay.
Okay, you want to try the same degrees and see if we get the same radians out?
Yes.
Yeah.
Okay, let's start with 36 degrees. Now, degrees is on top, right? Okay, now I need my degrees in the bottom. So degree label cancels out. What do I need in my numerator? Yep, pi radians. So I want this in terms of pi, right? I want my pi in there. So I want you to keep pi. So I should just do what? Not times, right? This is up top, right? I can kind of write it like that.
So do pi divided by 180?
No, I want it in terms of pi. I shouldn't be typing in pi to a calculator.
0.2.
That's what I did.
We're supposed to get 5, huh?
So we're doing 36 divided by 180. So if I multiply this out, I get 36
0.2.
radians. 0.6.
0.6. Oh, but I did. I got it.
Is it? Oh, 2 pi.
Yeah, 2 pi. 2 pi.
It's 0.6.
I got
0.6.
Pi. Brain break.
We only have 3 minutes. Okay, what is that? As
36 times pi?
0.2.
How do you keep 5?
Is that what you
I want you to keep pi in the answer. So if I want to keep pi in the answer, all I should be doing is dividing my degrees.
0.2 pi.
0.2 pi. Yeah, so 0.2 is written as what fraction?
I got 0.6.
2 pi.
Yeah, no.
Oh, 1/5. Oh my gosh, I'm a genius.
What was it, Jane? Yep, so if it's 0.2, how do I write that as a fraction?
1/5.
Yep, 1 over 5 pi, which is just pi divided by 5.
I got 0.62.
Okay. Mode. Everyone go to mode on their calculators. Did you multiply by pi?
Mode. Okay, what's
Yeah,
next?
pi and answer. Pi degree.
But if you plug that into the calculator.
What's
How,
Did
You
you
want
go?
it in terms of pi. You want
Mode.
so that's
So it was good. So if I multiply this, all you have to do is divide a degree by
so I got 0.2.
yeah, 0.2, which is the same thing as 1/5.
Times 5.
So I pi 5. Okay. Yeah, I'm trying to see if I should give you homework or not. Well, there's like one more thing to the lesson, so it's either like almost double homework tomorrow.
Double homework tomorrow.
Or
No, what the?
Yeah.
It's the same thing.
Okay, it's alright.
you guys are not geometry. You want algebra.
Rain break. Oh, we have that.
More. 1 more minute. I'm so nervous.
Wait, technically you could have a rain break now, but let's see.
Rain break time?
I mean, yeah, you only got 1 minute. What do you want to do? Play bus driver?
Talk about maybe not.
Oh, that is true.
This is not Jack and
Oh, wait, that's the.
No, this is just Jack and and that's
And David too?
And David.